All right, so now I'm doing this on the fly, give you something to look at for homework. Got a request for some new material. Most of you don't need new material yet. A lot of things you can still make gains on the last test, and you should stay there. However, I'm not going to hold anybody back. So every worksheet will have hopefully enough problems that you can work on something at your own pace. And if somebody needs new material, then I'm tacking on some new material. So got a worksheet, archived worksheet. I'll be sending to you an email. Well, obviously, if you're watching this video, you've already got it. So enough with that. You should do each problem after I put it on the board. Pause the video. I'm just going to do it so I can get out of here in an hour's time, I hope. I've got 3, 4, 5, 6, about 6 or 7 new things to think about that I'll start including in every worksheet. Not going to thoroughly explain them right now. I've got some videos already made. Got a nice storm coming through and I'm on Gilder duty tonight, so I'm pressed for time. So I'm just going to do this worksheet. I've starred the ones that, for those of you who asked, new material, go there first. Start thinking about it, look at it. And like all the other problems on here, we'll learn them over a period of time. All right, but there's plenty on here that was on the last test. And I'll try to go through this in a timely fashion, so I'm not here till midnight. So name 3 points on the line. Problem number 1, y equals -1/7, x plus 5 plus 4. You pause the video, and you should have come up with -5, 4, change by 7, 2, 9, 16. Keep doing that forever if you want. You got some friendly numbers, go down by 1. All right, that's what you're trying to learn how to do. Sort out your X's and your Y's and learn something about rates of change. Problem 1 done. Problem number 2, y equals mx plus b form. Well, that's a shame because I should have kept this on the board. -1/7 x plus 5 plus 4. And I do this problem solely to make sure you know how to multiply fractions and add and subtract fractions. Well, it's not solely. Should be able to sketch this as well from this perspective and the slope-intercept perspective. All right, back to mechanics. We talk about these things in class. Don't put the x there. We talked about that in class. Here, I'm talking already. -5/7, and now I want the number 4 to be written in terms of 7, so it's 28/7. So your answer should have been -1/7 x plus 23/7. All right, I'm going to discipline myself just to do the work mechanically. All right, problem number 3. Write the equation line that passes through -2, 7. Number 3, we want a -2 to turn into a 7. So we're measuring from change from -2 plus 7, and I'm talking again. And we want it to pass through 1, -3. All right, so put in a 1, x is changed by 3. We want to get -3, 7 to -3, I guess it's down 10. If I make a mistake here, it's because I'm rushing too much. That's why fire trucks are red. They're always rushing and rushing to red. All right, solve -2/5. Well, you have the sheet in front of you, so I don't have to say what number it is. -2/3 x minus 6 equals -22. All right, so what's the easiest way to do this? I think the easiest way to do this, move the 6 over, so that's -16. I'd multiply by 3. -2x equals -48. And negative and a negative is positive. Cut 48 in half and again 24. That one's done. Remember, you're pausing the video. Next problem, -5x minus 1 equals 2x minus 4. Make sure I got my eyesight here. I'm going to bring the minus that way and make it 7x. I'm going to bring the minus that way and make it 3. So 3/7 is the x value where those lines intersect. We've been graphing them in class. So expand 5 minus 3 x minus 2 squared. And why don't I write the x? I won't take any shortcuts here. -3, we're going to square this. It's x minus 2 times x minus 2. If you were taking the shortcut, you would have said -3 times x squared minus 4x plus 4. And then added the 5 and write your answer. -3x squared plus 12x, and do this in your head. -12 plus 5 minus 7. This is going to bring you to the same place. Put the 5 out here, take your time with the FOILing. X squared minus 2x minus 2x plus 4 plus 5. And if you do that out, brings you right back to there. All right. Name that tune. Again, conversion is really the multiplier in front of the major operation. It's all about operational change. I don't know what I'm talking again. 8, 3 through 15, 12. All right, the signature square root function, and we want x minus 8 plus 3. And what's the conversion? When I put 15 in, I get the square root of 7. That doesn't work. Square root of 7 plus 3 doesn't take me to 12. What takes me from 3 to 12? Up 9. Okay, we've talked about this. We'll talk about these conceptually in class, but that's the mechanics. All right, we got the inverse. Actually, I threw the inverse away. Instead of an 8 getting a 3 gets you an 8. Instead of a 12 getting you 15. No, yeah, I wanted 3, 8, and I wanted a 12 to get 15. I think that's the inverse of the values before. Signature squaring. All right, so we know we got x minus 3 squared plus 8. All right, and when you drop a 12 in, you get 12 minus 3 is 9 squared, 81. 81 plus 8 is not 15, so you convert 81 units of change into 7 units of change. And I should be writing y equals. I'm trying to do this quickly. There's my eraser. So, you're already looking at the next problem. I'll do it out so you can get a correct answer. Remember, you're working with minus b over 2a. You're plugging it in and you're taking the value of the function at minus b over 2a, and that's your vertex. Okay, I'm just going to do it a little differently. So I see 4, I see x, I know that's squared. I would have written, well, this is how I do it. I leave it like that. I divide the 4 into, first term's positive, second term's negative. So I know it's a minus. I put 4 into 16 and cut it in half, and that's 2. And then I like to say that if I put a 0 in, I never gave you the original equation. So the original equation is, you've got it in front of you, but somebody else is watching this on the internet. Minus 16x plus 5. Okay, I'll go through that again. This is what I know. I know that a 0 gets you 5. So I know that I'm going to start there. That's positive, that's negative. So I know opposite signs, I get a negative. Put 4 into 16, you get 4 cut in half, it's 2. When you square that and you put a 0 in, you don't get 5. You get 16. So how do you get from 16 to 5? You got to go down 11. You can take more time with it by working with the minus b over 2a form. Next, write the equation vertex 1, 1 through 5, 6. I think we've already done a problem like this, so I don't know why I'm doing it. So x minus 1 squared, always subtract the first x value, and simply write the second one. I don't know why I did this way. So now we also want to go through 5, 6. If I put a 5 in here, I get 16. So 16 units of change doesn't work. How do I get from 1 to 6? Put a 5 in there. Yeah, I hope I did that. 2x squared minus 7 equals 25 is our next problem. So 2x squared minus 7 equals 25. So what am I going to do? I'm going to add 7. Going to divide by 2. Going to take the plus minus square root. Square root of 16 is 4. And might as well check an answer, see if it works. Let's put negative 4 in. 16 times 2, 32 minus 7. Oh my goodness, it works. Next problem. Then you play this again. I'm doing it fast. There's nothing that says you can't play it again. Play it again. Play it again. Pause it if I'm talking too fast. Why don't you get to the point where, okay, I'm gonna, whatever it was to begin with, it was this, right? Okay, I'm gonna add 7. You know, you can say, okay, I'm gonna add 7. Boom. And then you'll see why that is what it is. The old guy's tired here. All right, most of you made mistakes on this next problem. Let's see if we can correct some of them and talk about it. First off, 2 plus 3, I think is 5. Is that because I'm really adding how many 1s there are in the problem? Right? 1's a common factor. And 1 times 2 plus 3 gets us 5. All right, so 2x plus 3x. Oh, I'm counting x's. So it's 5x. How about I go 2x squared plus 3x squared? Oh, yeah, counting x squared, it's 5x squared. We've been doing, I'm not telling you anything new. But what if I had said, let's add up 7x squared y to the fourth plus 2x squared y to the fourth? Right? What am I adding? X squared y to the fourth. How many do I have? I got 9 of them. Got 9 of them. Now, why am I doing that? Because in the following problem, we butchered the exponential situation here. All right, so now let's look at the one that gave the group lots of pause on the last test. We have 3a10 x squared minus 2y to the fourth. And I'm squaring it. All right, let's talk about a to the 10th squared. A to the 10th times a to the 10th. Well, a to the 10th is a times, can I do a smaller one here? Can I just look at what do you get when you do a to the third squared? Right? A to the third squared is a times a, that's a squared, times a to the another a, gets me a to the third. And I'm doing that 2 times. Here's the first time, here's the second time. And now we're saying, is there a quicker way of saying that? Oh yeah, it's a to the 6th. Okay, so the rule is power to power you multiply. Now what if I had a to the 6th, 2 of them, and then I had 3 of them? I think I got 5 of them. All right, so the shortcut is you square this. Well, what's 3 squared? 9. What's a to the 10th squared? A to the 20th. What is x squared squared? 2 times 2, 4. Now, we're going to double the product. Well, the product here is minus 2 times 3 is minus 6. I'm just going to get the product first. And then we're multiplying by a to the 10th, x squared, and y to the 4th. All right? And if you do the foiling, right, I'm just going to do a plus b. A plus, you got to generalize a little bit at some point. A times b is ab, and a times b is another ab. So if I count those, I have 2ab. Oh God, I hope I got this camera so you can see everything. Oh good, because I don't want to start this again. All right, so if we FOIL this, right, we got 2 of them, which means I've got 2 of these things here. Minus 6a10 x squared y to the 4th. All right, I guess I can't take the shortcut with this one probably because people might not see what's going on. So here we go. All right, minus 2y to the 4th. That's the squaring process. I hope you can see there's 1 of them and then there's 2 of them for middle terms. All right, and if you square the last one, we've talked about the last number squared is minus 2y to the 4th. It should be in parentheses, which means I'm squaring a negative, a positive. I'm squaring the number 2, which is 4. I'm squaring y to the 4th, which is y to the 8th. Remember, power to power, you multiply, and you need to know that rule. If you don't know that rule, you're going to struggle mightily with high school mathematics. Okay, so memorize that rule and hopefully understand where it came from. Go back 2 minutes in the video, look at it again. All right, so what's this now? This is where people struggled all over the place. People changed the exponents, but we're counting now. What are we at? What are we counting? We're counting that number. All right, whatever that number is, I got minus 6 of them. It's kind of like saying minus 6 of that amount, minus 6 of the same amount. Well, I think that's minus 12. And the exponents don't change here. Hey, did I? No, good thing I didn't change them. All right, so we got 9a squared x to the 4th minus 12 a10 x squared y4 plus 4y to the 8th. Now, since we struggle with that, I'm going to make a new one and just do the shortcut. You can take your time. If you're struggling with it, take your time, do the FOILing, right? But I'm just going to get you the right answer to a new one. I'll make the numbers a little smaller. Let's go with 5x7y8. Let's do a positive this time. Plus, now let's stay negative. Minus 3. How about we go a4, and let's square that. You got to square the 5. You got to square that, which is 14. You got to square that. It's 2 times 8 is 16. You got 5 times minus 3 is minus 15. We know we're going to double it. minus 30. Of what? Of these things. X to the 7th, y to the 8th, a to the 4th. Probably should have put the a first and read it alphabetically in order. All right, and then you got to square a negative, which is a positive. You got to square the 3, which is a 9. Then you got to square a to the 4th, a to the 8th, and that's going to be on every worksheet and every test every day until the end of the term. So I'm no rush here. I am in a rush, trying to get this done in under an hour, right? But you shouldn't be in a rush. Take your time with it, see it every day, and hopefully by 2 weeks from now, you can just write your answer. That's it. Takes some time to learn. But hopefully you follow the video, you ask how to do it in class if you're making mistakes, and hopefully if you got your eyes open and you're paying attention, a couple of weeks from now, that won't give you trouble. Alrighty, where are we? All right, totally new, difference of two cubes. So let's get a couple of cubes we're familiar with. We're familiar with 27 and 8, and we're familiar with, I do it down here, 27 minus 8 and plus 8. Those are cubes. Cubes, boxes, right? You've done some of those drawing. And guess what? Just like the difference of squares, we can't do the sum of squares, but we can do a difference of squares. You're learning how to do 9 minus 4, right? Which is 3 plus 2, 3 minus 2. And we've been drawing the square, and what's 3? The square root. So what are we going to do with the cubes? We're going to work with the cube roots. What's the cube root of 27? The cube root of 27 is 3. What's the cube root of 8 is 2. We're going to work with those two numbers. And we're just going to write the answer. So if it's a positive, it stays a positive. If it's a negative, the first parenthesis is a negative. All right, then we work with these numbers. The next term is the square of the first term, 9. Is 3 times 9, 27? Yes. The last term is the square of the second cube root. Okay? Now, this multiplication does not come out to 19. I got a video on completing the cube that too, but the sum and differences of cubes. After you see this, we'll talk about it in class tomorrow, and then we'll show the video for homework, and you'll get more time to practice on this. Just introducing the topic, mechanical introduction, a little bit of conceptualization here, right? 27 and 8, right? Cubes. All right. So the question is, what goes here? It turns out that it's the difference of this product. 2 times 3 is positive, 6 is negative. All right, so this becomes 5 times, looks like it's 7. 5 times 7 is 35. And guess what? 27 plus 8 is not 19. You probably caught that, is 35. They're the same. So I could have written this thing as a product. This product would have been 3 plus 2. Square the first term, that product, change the sign, square the last term, and you've got 35 written as a product. All right, guessing, maybe you're guessing already. So this is square the first term, the product's negative 6, you make it positive 6, and then square the last term, so the first and last term are always positive. And 3 minus 2 is 1, and this is 19, and what's 1 times 19? 27 minus 8. So I express this subtraction as a multiplication, which could help me if I have some division in a problem in terms of simplification. So that's a new topic. And now I'll do the one that's on the sheet. And I guess I had to introduce it a little bit. So the one on the sheet is 125m cubed. That's a volume statement. Minus 64, that's a volume statement. What's the cube root of this? 5m. Oh, I wrote squared. Okay, rushing a little too much. There, that's what's on the sheet. So that's the cube root of that one. What's the cube root of 64? 4. It's a subtraction. So there's your first parentheses. How do we build the second parentheses? We square the first term. Remember the rule of 4 now. This is day 1, and I'm not really spending a lot of time on it. By the time we do 4 days in a row, this is going to mean something different to you, just like the equation of a line, which most of you can do now. Some of you are still making careless addition and subtraction errors, but conceptually you know what you're doing. Day 1, that wasn't the case. Day 4, pretty much everybody there conceptually. All right, so the product's minus 20m. I'll do positive 20m, and that squared is 16. Now, 2 things times 3 things is 6 things.
But we only have 2 terms. So 2 terms by 3 terms is 6 terms. We only have 2. There's got to be some cancellation here. So I'm going to do this out once. We'll do it in class more. 5 times 25 is 125. M times m squared is m cubed. All I'm doing is bringing an m. So this is going to be 20. Oh no, I'm doing 5 here. Mike. Repeat. 5 times 20 is 100. And m times m is m squared. And 5m times 16 is 80m. Now I'm going to do 4 times, negative 4 times 25m squared is minus 100m squared. Minus 4 times 6 times 20, sorry, minus 4 times 20 is minus 80m. And minus 4 times 16 is minus 64. And lo and behold, 6 terms becomes 2 terms. 125m cubed minus 64, which is what we started with. So that could have been written this way. That's a subtraction statement. This is a multiplication statement. Same calculation. If I put numbers in for m, and I'm not going to take too long, I think, well, I could put a 1 in. Right? If I put a 1 in, I get 36, 56, 61 units. If I put a 1 in, if I put a 1 in here, I get 5 minus 4 is 1. Over here, I get 25 plus 20 plus 16. That's 45, 55, 61. Oh, yeah, I got the same answer. By plugging 1 in here and plugging 1 in here, they're the same calculation. All right. All right. And you can play that again, but we'll be doing it again in class. For those of you who are actually watching this. Okay, I'm just going to do this one really quick and ask until the y equals 6. So y equals 6 is that graph. And I have an exponential function that passes through the point 1950. There's no way you're going to get this in one look unless you're brilliant. All right? And maybe you are. All right, so on this sheet I have 2016. All right, so let me give you a physical context here. Not that it's a real one. Let's say we always have sheep in the town of Gill. And there have always been at least 6 sheep. For a history, forever. But over time, those sheep started, making more sheep. And so in 1950, we had an increase of 5 in the population. And by the year 2000, we had an increase from this amount from time immemorial in the history of the past, in Gill's history. We went from 6 to 16. That's up 10. It looks like this amount doubled in 50 years. Wow. Well, how would I write this equation quickly? Then we're going to launch ourselves into some discussions of exponentials. Now, why am I doing exponentials at this level? Because students are coming into my pre-cal and calculus and even algebra 2 classes with only one mindset: linear. Everything's linear. Boy, does it get in the way. And I've talked with teachers who think the A term. I've heard so many teachers, and I said, well, what's the A term mean to you? And they say the slope of the quadratic. And I'm like, okay, all right, well, that's a linear mindset. And we can't have a linear mindset because there's a lot of other functions besides linear ones. And every function has its own mindset. All right, so I'm just going to write this equation. You can look and start looking at where the numbers go. And so I'm going to say this is a function based on time. This is a timeline, history. Here's history time. Right? So the first time I have 1950, the other is 2000. But I'm talking sheep. So f of t is really a y equals statement based on time. So most important is 6. All right, so could have written it this way: 6. How do I get to 11? Add 5. Next time I didn't add 5. Next time I did not add 5. The next time I added 10. Well, there's our doubling. Okay, so there's the base of the exponential function. 1950, I'll highlight it by saying t minus 1950. And then I'll divide by 50 because that's how many units of change there are. So let's put 1950 in. I hope that some of you can do that calculation. Pause the video. You have done right along. Well, I got something to the 0. And I'm going to make 10 the number 2, 10 over 5 the number 2. And so if I put 1950 and I have 10 to the 0, I hope you know what that is. It's 1. 1 times 5 is 5, plus 6 is 11. I've now made that a correlation. Now let's put the number 2000 in there. All right, and I got videos tomorrow night. Start this much easier, but I'm pressed for time. Thunderstorm coming, oh my God. So 2000 minus 1950 is 50. What's 50 divided by 50? It is 1. What's 2 to the 1? 2 times 5, I jump to 10, plus 6 is 16. Once you learn the hang of this, and it usually takes about 4 days, you can write this as quickly as write the equation of a line. Maybe 2 seconds longer because there's more terms. But it's just as easy. Might be easier to see than the equation of a line, I don't know. All right, so that's new. You asked for new, that's new. We're gonna do it now. That's part of our repertoire going until the end of the term. All right, number 16, you've had this before. 8/27, everything that we're doing here right now. For some of you is already mastered, for others you're trying to get there. But none of the problems I think you could have done a week ago Monday. So first thing I'm gonna do is the reciprocation because it's easiest to do that right now. That gives me 2/3. I don't know what 27 squared is, but I sure know what the cube root of 27 is. It's 3, and I know the cube root of 8 is 2. So that's the order I would have done them in. I still haven't squared. So you should have an answer of 9/4, and I hope the numbers speak for themselves. Okay, log 9 base 3, I'll do it in 2 ways. The first, just write the answer. So what do I have to do to a 9 to get a 3? I gotta take a square root. And that's what 1/2 means. 9 to the 1/2 means that you are doing this. That worked better with machinery years ago, and I don't know if it's that necessary now that computers have evolved to be able to handle more language. All right, so now, if you didn't understand that, then you gotta say, okay, I don't know what it is. Well, you're learning that this is an exponent. Exponents go on top of bases. And now we're looking for the same multiple. We're looking at multiples of 3. So 9 is 3 squared. You know, you got to do 3 times 3 twice to get to 9. So it's a multiple. And 3 is to the first power. And this is raised to an x. And so we talked about that in class. And there's your 1/2. Right? But it's nice if you can just look at the log and say, I know the operations to turn that into that. Exponential operations. And that's what you get on the next problem. So I'll give you a chance to see if you can sort it out without having to write anything. I've had students do that. They just look at it and say, I know the answer. So you try it, see if you can develop that skill. All right, you're pausing the video. Well, when I look at this, I know that multiples of 16 and 8, it's 2. I know that 2 is linking those. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, and there's the 2 numbers I'm working with. So what do I have here? Well, I know I got to flip, right? I know that this is 1/18. This is, I know I got to flip. I know that 16 can become a 2 if I have a 4th root, right? 4th root of 16 is 2. And if I want to get, where was I? I totally lost myself. So I've got to get an 8, and I got to turn the number 2 into an 8. I guess I got a cube. Okay, so now let's say you didn't know that answer from that process, but you keep trying that in class. For those of you who can do the next step here, which is algebraically derive that answer, push yourself before you do the problem. See if you can see the operations that you need to perform, and you're deepening your understanding of this calculation. All right, so we got 16 to what power equals 8? We said 16 is a multiple of 2. And we know it's 4 times, and there's our exponent, and we know 8 is a multiple. I want 1/8, sorry. 1/8, so that I hope I can just say 2 to the -3. I did talk to everybody in class today, right? You gotta get a flip here, right? Let me write -3 a little better. All right, so what do we have? The rule of exponents, 4x equals -3. And we're coming right back to our answer of -3/4. And that's really not an answer -3/4. The answer really is 3 exponential operations. What are the 3 operations that we're doing to 16? Well, we're taking a 4th root, which makes it a 2. That takes care of that operation. We're cubing it, which makes it an 8. That takes it a cube. And the minus means we're taking a reciprocal. And that's how we arrive at a correct response. Okay, so it's language. You're trying to learn the language. This is on every test, every worksheet, the rest of the term. Stick with it till you get it. And if you do it that many times, you might actually remember it when you see it again. So again, another practice. Log base 9 to 27. Okay, what do I have to do to a 9? I think I got to take the square root. How do I turn it into 27? 3. You don't know how to get that from just looking at it, then you got to do 9 to the x equals 27. What's the common multiple? 3. 9 is 3 squared. We're raising that to the x. 27 is 3 to the 3. All right, same base. That means 2x has to equal 3. And again, we're arriving at that solution. Okay, new problem. I'm just going to do it mechanically, and we'll really dive into it in more depth conceptually during one of our workshops in the morning and afternoon. So x squared, I will do show a little bit. X squared minus 14x, and we've got y squared plus 2y equals 50. All right, and this is the equation of a circle. And how you get there is a Pythagorean relationship. We have done one in class. Do you remember doing x squared plus y squared equals 25? I hope so. And you found 0, 5 and 5, 0 and eventually 3, 4. That's what we did in class. Right? We did a bunch of that. All right. So x squared minus 14x is not a square. It's x times x minus 14. Mathematicians like to call it a quadratic. Very arrogant of us. It's a rectangle. Quadratics are just rectangles. We're studying rectangles. All right. Pythagoras is all about squares. So how am I going to do that? Well, this looks like it's longer. Probably should be shorter. But this side is I'm going to take some off of that side and put it on this side and balance it off. So that means I took the average of this number, which means I cut it in half. Okay. Now, when I do this, I think we're getting better at this. I hope you can see that when squared is actually x squared minus 14x plus 49. But I only want this. Well, how can I turn that into this? Yeah, minus 49. Okay, and so I'm just doing mechanical here. I know you're probably looking at it and your head's spinning, but so was your head when I did the equation of a line 4 or 5 days ago. It's not spinning anymore. So I got to take the average. I got to cut this number in half. Right? There's no constant up here. But when you square here, you get 1. I don't see plus 1 up here. So therefore, you get rid of it. And that gets us 50. All right, so now what do I do? To make it a squared plus b squared equals c squared. I take these numbers and move them over. That gets me x minus 7 squared plus y minus 1 squared equals 100. And that's something squared. Why don't I write it as 10 squared? And that's the Pythagorean relationship. And the center is at 7, 1. And this is 10 units. And if I make this one longer, you know what we're really doing here. And I got to explain this in class, but at least you're getting a little look at it. So this is the Pythagorean relationship of that square area and that square area equals that square area. And if this one gets bigger, that one's got to get smaller and we get a rotation. And that's that. No, not enough time for you to learn this, but to see it at least once and think about it, yeah, fun. Oh, I should have told you, I should have graphed that and shown you the domain and range because we talked about that at the end of class today. But I'm going to keep going. F of x, if I'm on duty tonight, I got to make sure, get a bite to eat, got some errands to run. So I'm doing the best I can. G of x equals 10x to the 5th. Oh, I'm still seeing this on the camera. Yes, 10x to the 5th plus 1. And we're going to do the following. We're going to do f of 5/9. There's nothing new about that. So f of 5/9 is 3/2 times 5/9 plus 1. And if you don't know how to multiply those fractions, when you see the answer here, there's an easier way to do it, but I'm not going to take any shortcuts. Well, I will afterwards. So 3 times 5 is 15. 2 times 9 is 18 times, I forgot to put the x, I'm sorry. The x. I replaced it with x. All I'm doing is an evaluation, sorry. So this is an evaluation. I'm putting a value into the calculation, finding out the answer. I got to add 1. I'll do this first. So that's 15/18 plus 1. We could have reduced 15/18 by taking 3 out of the picture from the beginning, but I'll reduce the 3 here by 6 plus 1. and I'll write one as 6, 6, and there's 11, 6. I hope I'm not making too many careless errors as we play through this. All right, so that's what it means to do f of 5/9. It means replace x with 5/9, and then do the math, and then learn how to do the math. And then, next question, nothing new here. F of g of -2. And we do, that's where please pardon my dear Aunt Sally comes into play. We do the parentheses first. And g of -2 is in the parentheses, so what's g of -2? G of -2 is plugging -2 into x to the 5th. And if you do a -5 times, a minus times a minus times a minus times a minus times a minus, an odd number of times, you get a negative. And 2 to the 5th is 2 times 2 times 2 times 2 times 2, which is 32. And 32 times 10, well, in this case, -32. So if I put that in, I get -32. And if I multiply that by 10 and add 1, I get -320. And when I add 1, I get -319. Oh my God, I'm not gonna have you do the rest of it. I'm not gonna have you do this out, because I don't want to do it now. I thought I gave you something that was easy to work with, and it certainly is not. So I gotta do that number now, and I gotta plug it in for x. I gotta do -319 plus 1. I just don't feel like doing it. I'm already spinning from all the work we did today. So if you want to take the time to do it, go ahead. It's not that hard. I should do it. I gave it to you, I should do it. So 3 9s are 7, so that's a 5, so that's a 9, and that's a negative, and that's over 2 plus 1. 1 is 2 plus 2, so it's not that bad. So it's -955 over 2, if I didn't make a careless error, and I may well have. But that's the concept. I don't know, why did I erase that? F of x, I can't even remember what it was. 3 halves x plus 1, I think that's what it was. Yeah, pretty sure. And so the last one here is the inverse. All right, so we're going to find the inverse of that calculation. All right. Well, it's like solving an equation. But when you solve an equation, that becomes x equal. So let's make an equation. Let's pick the number that will get us the right answer every time. And that's 0. All right, so pretend you're solving that equation for 0. What would be the first thing you do? Well, I hope you'd subtract 1. I hope you'd multiply by 2. And this is a new number, so it needs to be both parts multiplied by 2. And then I hope you divide by 3. And that would get us that, I hope. So if I plug in, I'd have to do it with the number, but this is the inverse. So let's find something that, a table value that's easy to work with. How about 10? I hope I didn't make a mistake here. So let's put 10 there. Well, I would divide it by 2 first, because that's easier. That's 5 times 3. 15 plus 1 is 16. Well, if this is true, then a 16 has to get us a 10. That's not a formal proof, but we're not going to do the formal proof. We're just learning this part right now. So let's put 16 in. 16 minus 1, 15. Well, I know 3 goes into 15 5 times, and 2 times 5 is 10. I liked my answer. So let me get it back for you again, so you don't have to worry about the computer here. So I start with my answer. It's going to come from subtracting 1, doubling, and then dividing by 3. That's the inverse. Inverses can be handy if you have a lot of equations to solve. You don't have to go through that every time. You can do it as an evaluation now. So if I wanted to know what is f minus 1 of x, and I didn't have the inverse, and I wanted to know what is f minus 1 of, what we'll say 20, well, then all I know how to do is solve this for 20. Let's make it 21. Make it 21. And I can tell you what that answer is by solving it now. So there's 20, there's 40, 40 thirds. I don't know why I did that. Having a little fun, maybe. All right, what's the next one? Nope, I got the sheet, you don't. 3 halves minus 5 sevenths. We talked about bingo, bango, bongo. 3 halves minus 5 sevenths. All right, bingo, 3 times 7, 21, bango. So bingo, bango, bongo is really that configuration, and that can take care of so many fractions. You want to learn it. So, what are you going to do? You're going to multiply by 7 by 7. That's what you're taught in grade school, right? Well, 2 times 7 is 14. We could have written that without having to do that. And 3 times 7, well, I can see 3 times 7 right now. And I can see 2 times 5 right now. And so now I've got 21 minus 10 is 11/14. You can do it in your head. 21 minus 10, 11 over 14. Okay, now what happens is when we express these numbers in more than one term. So here's a bingo, bango, bongo. I'll show you how to do it. And then we'll do it every day in class and talk about it in more depth. Right now, I'm just laying out a new problem. Minus, and I'm not, I wish I was giving you 4 or 5 examples of it, but pressed for time. All right, so you got a couple of fractions here, you're subtracting. Bingo. Take the symbol, whatever it is, keep it. So now all you have to do is multiply that times that. Don't worry about the signs. 5 times, don't worry about this sign. 5 times x is 5x, 5 times -2 is -10. 5 times x is 5x. Well, that's nice. Didn't know if I meant that. Oh, why didn't I put it over 5? Oh my God. Sorry. Let's make it a 6. Right? Yeah. Going too fast here. Again. Boom. You probably were wondering why I was doing anything like that. You already had a common denominator, right? Didn't have to do anything. So now we're multiplying x minus 2 times 6. It's easier to say 6 times x minus 2, which is 6x minus 12. 5 times x plus 4 is 5x plus 20. And now maybe you'll see why we're doing that, because this is in a box. And 5 times 6 is 30. Okay? So 6x minus 5x is x minus 12 minus 20. This helps you see the distribution of that negative. Minus 12 minus 20 is minus 32. I don't need up down here. Don't need the boxes anymore. And 5 times 6 is 30. And we'll prove that that's true in class. Take more time with it. And so that's going to happen. But right now, some people ask for some new material. Just throwing it out there, along with practice with a lot of the older stuff. All right, so what do we got? We got getting towards the end. I got to upload this. So we're looking at minus x over 4. I got to get a new marker. And I actually came prepared. I put one in my pocket before this started. Just lost that one on the chair. All right, so we're looking at thunderstorm coming. Should be rolling in here in about 5 to 10 minutes. Minus x over 4. Minus 4. Why did I do minus? I don't like to put the same number. That's okay. 2x over 5 plus 1. Yeah, we got a couple of lines here. We want to know where they intersect. The fractions are in the way. Get rid of them. Make everything bigger, each term bigger, and it's still equal. We've looked at that in class. Do the division first, then the multiplication. 4 goes into 20, so minus 5x. 20 times -4 minus 80. A lot of times people forget to do that, so be careful. 5 into 24 times 2x is 8x. And 20 times 1 is 20. A lot of you got this right on the last test. I'll bring the 5x that way. 13x, I'll take 20 away here, minus 100. So that's minus 100 over 13. We could graph that and do that in class so we can see it from a graphical perspective. And that's the practice for that problem, the mechanics. Remember, you're trying everything before I do the problem. And then you pause the video, look at the solution to figure out if you made a mistake, where and why. All right, so we're graphing. No, we're not graphing. We're doing 7 minus 4i squared. I'm going to take the shortcut. I hope you begin to. I hope you begin to see the pattern. Square, square, always positives. Minus 28 becomes minus what, 56? Okay, we've talked about what I squared does. I'm going to use the eraser. It changes the sign of the number in front of it. 49 minus 16 is 33 minus 56. You keep doing that problem out till you see that. All right, where are we at? We're at y equals, yeah, rumble of thunder, it's coming. Minus 2x squared plus 12x plus 5. We're going to sketch it. No, I'm skipping the problem. Keep wanting to jump to that. We will quickly. 3 log 3 log means 3 times log base 2 of x minus 4 plus 5 equals 14. How do you solve any 3 times some amount? We don't know it yet. Plus 5 equals 14. What would you do first? You'd isolate the amount. So we subtract 5. And then we divide by 3. And we've isolated this log base 2 of x minus 4. And I hope you're starting to get a feeling for how you rewrite this. That's an exponent on top of the base. So we'll do that. And that equals x minus 4. I think we can do this. I think we can see 8 equals x minus 4 and x is 12. So we put a 12 here. 12 minus 4 is 8. Well, we've been practicing that. What do you put on top of the 2 to get an 8? A 3. 3 times 3 is 9. Plus 5 is 14. All right. And if you want, if you learn how to graph exponentials, I'll teach you how to graph logs. And you might be one of the only ones that can do it, because I ask people how to graph logs all the time. They generally don't know. So where are we at? We're at the equation perpendicular. 7x plus 2y equals 19. Perpendicular to that, well, we got to find the slope. So 2y equals minus 7x plus 19. All I did was move that to the other side, divide by 2. Equals minus 7 is being divided by 2 times x plus 19 divided by 2. I hope you know where to look for rate of change. The rate of change of this is minus 7 over 2. And we said that the perpendicular, all right, the perpendicular slope is reciprocal, and change the sign. If we got one line going down, we got another going up to form a 90 degree. So this is going down, therefore the reciprocal 2 to 7 changes, boom, rise over run, changes, run over rise. I do a better job of drawing that. And we usually put it through something. What are we putting it through? Oh, check is your x value, and the answer is your y. If I ever give you words, just work with the capitals. So we get x minus c plus a. And if you check, you put check as an input. C minus C is 0 times anything is 0. If you start checking, you're probably going to get more right answers. All right, I'm going to do some quick graphs. Write you an email. Scan this document, send it to you. Bon voyage. 2x minus 3y equals 30. All right, you've been doing this for 8 days now. You should immediately know that if you let x equal 0, we can see negative 10. If you let y equal 0, you should be able to see 15. So 15 is a little further out, and negative 10 is down. There's your line, and you don't have to do any work. You know how to use that sentence. Finding the intercepts. Y plus 1. This is textbook. Point slope. How do you graph point slope? You find a point and you use the slope. Equals 2/3 x plus 3. Right? So what makes 0? What makes 0? Negative 3, negative 1. So negative 3, negative 1 is a point on this line. I still think putting the positive 1 over here is a better form. I think you can see negative 3, negative 1 more easily. So we go to negative 3. Let's call that 1 unit. Negative 3 down 1. We're about there. There's negative 3, negative 1. And what are we doing from there? Going up 2. So ratio of whatever, if that's 2 units, 3 is a little bit longer than that. Yeah, somewhere like that. Right? And I suppose we could nail it by changing by 3. So that's 0. And changing by 2, 1. Does it look like I went through 0, 1? Pretty good. Pretty good. Right? You can do that as well. Right? So that's graphed. That's called point slope form, because we graph the point. And I use the slope to get another point. So y equals minus 2x squared plus 12x plus 5. At the end of the term, I want to know if you know that's cup shaped down. I want to know if you can name the vertex. The vertex comes from minus b over 2a. And so that's minus 12 divided by minus 4, which is positive 3. So there we go, we got that. If we want to find the y value, we can use this equation because that finds y values if we have an x and we have an x. So this becomes minus 18, that's 36. I hope you recognize that this is correct because of that ratio. And add 5, and if you do that out, you got 18 plus 5 is 23. And I hope you know that that's the y-intercept, and you're on the increasing side, so 0, 5. You're done. If you want to put 6, 5 over here for more clarity, feel free. But that's a unique graph. All right, now we got an exponential. Oh, a little repetition here on a graph. This is good. Now you got the equation. So let's say that y equals, it says f of t, but I'll use y, you're more familiar. Plus 3, I'll change 6 over 3 to the number 2. And we got t minus 1999 over 23. See if you remember anything from a half an hour ago. So this graph is situated on top of y equals 11. That's a constant, that's not changing. All the growth is happening here. I'm doubling something. If I'm doubling something, double, double, double. I hope you see that. That was in the news for the past couple of years. COVID, when it hit New York, slow, but then it started to double every 3 days, something like that. And Dr. Fauci would come in and said, we gotta flatten the curve. We gotta flatten the curve. Why? Because the area under the curve represents how many people are getting sick. All right, so transmission, or maybe I might not have said that properly, but you know, we don't want exponential virus. We got another one, B5, coming our way. Hopefully the vaccines will work. All right, so this is an exponential curve. That number is bigger than 1. There are 2 types of graph, exponential growth and exponential decay. We'll talk about it. Some of you shouldn't be talking about this yet. You got enough on the sheet you got to work on, but this is something that people who have asked for new material are going to be able to do, I think. So there we go. Can we recognize the x values now? Well, 1999. Let's plug it in. That becomes 0. Anything to the 0 is 1. I get a jump to 3. 3 plus 11 is 14. And that happened in the year 1999. Okay, 23 years tells me 23 years later, 2022 right now, 23 years later, that 3 is getting doubled and it's going to be 6 units of change. But let's put 2022 in there. 2022 minus 1999 is 23. What happens to the 23? They cancel. 2 to the 1 is 2. 2 times 3 is 6 on top of 11. Takes me to 17. I'll take a lot more time with this another time. Right? Just getting, so this is 14. This is 2022. I'm done with my graph. You don't need to see this, but it's good training wheels. And there's your graph. You need 2 points, an understanding of the shape, and what's called an asymptote. So there's 4 things you got to learn to do. Get that mechanically. We'll be talking about it conceptually the rest of your high school career. All right, so now, almost done, thank God. All right, so what do I know about y equals -2 over root 3? And that I hope you learn. It's a square root function. But it's minus, so from 5, I'm going down. So it looks like that. Okay, 4, 5 is the end point. You put a number like 3 in, you're talking about -1, you're talking about imaginaries, and they don't exist. Not part of the graph. So the domain of this is x values greater than or equal to 4. I see the square root of 3. The only way that that happens is to put a 7 in. So I'll put a 7 in. 7 minus 4 is the square root of 3. They cancel, and -2 plus 5 is 3. That's a unique graph. What else do I want to say? The range. Well, the range is off the y value. This is the highest y value I have, is equal to 5. So the range is all the y values are less than or equal to 5. That's a question of domain and range. Last problem, I can shut this off, upload it, go and get something to eat. I think the store missed us. Got all this sequestering you, jailing you in the dining hall, and nothing hit us. Maybe it's still coming. 2x minus 3y equals 4. We already did one of those, I think, right? So 0 gets you negative 4/3, 0 gets you 2. Plot those 2 points, negative 4/3, 2 zeros a little further out. You got yourself your line
Without too much trouble. All right, I'm stopping this. I'm still standing. This is great. After guild duty tonight, we'll see if I'm still standing. Sit down. I get to sit down now. I get to look at the clock. Ah, it's only 6 o'clock. I'm gonna get to eat. All right, there we go. We'll talk about for those of you who you shouldn't be looking at the new material too much. It doesn't hurt you to look at it, but I wouldn't sit there and try to figure it out. It's not how math works. Just let it go. Presenting it again tomorrow. Let it go again. Presenting it again the next day. Maybe you see a little something. Presenting it again, videotapes online you can look at, so on and so forth. And hopefully 4 days from now, you might be making some gains. And some of you may get it right off the bat, but sometimes it takes days. All right, let's see, end.